Number 5. Now, I don't condone criminal activity in any way, but suppose you're a thief, overhearing someone's safe combination. That code consists of a 5-digit number. Every digit, 0 to 9. You're sure that there is at least 1 6 somewhere in the code. How many codes do you have to check? What are all the possibilities with this added restriction, this added information, that there is a 6 somewhere in the code? Let's make a list. Let's say here examples of possible codes. Give me a possible code that I would have to check. Because I want to understand, what am I looking for here? What am I trying to count? So by making little examples, I sort of solidify what I'm looking for. And just help myself be aware of what I'm looking for. Give me an example of a code. Yeah. 1 1 1 1 1. Is that valid?
No.
No. It has to have at least 1 6. Okay. But by doing that, I remind myself, no, wait. I have to read carefully. Give me a valid one.
3 2 6 5 9.
3 2 6 5 9. Do few. She did hers.
5 1 4 8 6.
5 1 4 8 6. Give me your actual code. Anyone else?
6 6 6 6 6.
Okay, I like it. It's 5 6. It's okay. Not 3. Everything's okay. It doesn't have to be just 1 6. At least 1. What does at least 1 mean?
So it could be a little more.
At least 1. I have to be aware of all these words. Yes. If I have to get rid of this at least word, and I want to rephrase at least 1 6.
It has to be 1 6.
Only one?
One or more.
There's
One or more. One or more. Just a different way of saying the same thing. We know what it means. One, let's say like this. So 1, 2, 3, 4, 5, 6. So when they say at least 1 6, there's a lot of different, more precise possibilities that's covered in that restriction. At least 1 6 is vague. 1, 2, 3, 4, 5, I don't know how many. It's all covered in this one little phrase. Could have 2 6s. Anything from 1 to all of them being a 6. Everyone happy with what I'm looking for? Silly as it is, I know it feels silly to make random examples, but it does a lot of good in just helping me understand what I'm looking for. I still do it, and it helps a lot. Once I have a clear idea, what am I looking for? What does at least 1 6 mean? I have 5 different possibilities inside there. So, this bothers me a little. How can I do this in one go without knowing exactly how many 6s there are? When I'm trying to cover all the possibilities. If I go using my previous strategy, is that gonna work? Am I guaranteed to have every possible code and to only have the valid ones? Can I do it like this? Obviously I asked, so the answer is no, but why not? Give me an attempt. What would you say here? Trying to do this in one go. Obviously I have 5 positions that I'm trying to fill.
You can't include and you can't exclude. So, like you can.
With this argument, you're right. She says you can include 6 and you can't exclude it. I can't know for sure. What would you try and put here? Number of choices for position 1. 1? What are you choosing there? Just one choice.
Cancel out your 6.
Okay, so he said put a 6 right there. And then? 9 choices? 10 choices?
It'd be nice because
It'd be 9 because you have to know your 6.
At least 6.
No, but 6 is something again. 6 is a lot more.
This is exactly the problem. There's no right answer. He said 9 because he already took care of the 6 and now he doesn't want a 6 anymore. What are you counting then?
No,
You're
I
counting,
say 9 because it says 0 to 9. It doesn't say 0 to 10.
how many numbers are there in numbers 0 to 9? 10 numbers. So 10, okay, you don't like the 9. Okay. Okay, 10, that's fine. Okay.
Yeah, if you learn something.
What about the next one? 10? And so on. So this is and maybe many of you, the strategy or the 10. So what do I do when I want, okay. So for example, is this guy counted among the ones you're constructing here? How many of you say yes? How many of you say no? How many of you say yes? That is one of the examples. If I go down the line, I can't possibly have that go.
You have to reorganize it back.
No, just as this is. Just like this. No, because choice 1 is a 6. So the only ones you're counting here are the codes starting with 6. So this guy is covered. Yeah.
You gotta times it by 5 because that's the positions that there is for the 6 to be in.
She says,
No, like I did that. Well, I guess you could do that, but I did that as 1 and then times the total number by 5.
okay.
because it's
So I agree that these are valid because I've guaranteed there's a 6. So everything I'm getting here, good. These are all we want. Well, all of these we want. There's nothing that I'm counting here that isn't in this list. But then I notice the list isn't complete. So she says, okay, take this. 1 times 10 times 10 times 10 times 10 and multiply it by 5. Or, let me do it a different way. She says I have to also include 10 with my 6 in the second position, all choices for the other guys. And then also 10, 10, 1, 10, 10 for all the different positions that 6 can be in. And I'll get 5 different ones. And essentially it's the same number. That's what she said. Yeah?
You have to account for
Now, every time here, do I get only valid codes? Yeah, because I guarantee the 6 is in there. Is there anyone that feels something strange in this area over here?
What is it?
In this area over here. Sure, everything makes sense. He's like, yeah, already. Torture. Every time we break it down like this, we get valid code. And then she says essentially, instead of timesing it, I'll just add them all like this to emphasize that all of these now I'm adding together. That's the first scenario. Second one, that I needed to separate so that the 6 is in a different position. Let's keep going here. Let's do this next one. And 2 more. 2 more. I just want to be sure that everyone understands this, where this comes from. I didn't say it was right. I want to understand this is the first attempt. Is everyone happy with why we're adding them all together? Because I need to make sure a 6 can't just be in the first position, could be second, third, and so on. Now, why is that not correct? I mean, why is it not correct?
Because you're lazy.
Sorry, my hearing, at my age, hearing is not good. I am really lazy, if that's what you said.
It's just at least 1 6, like, you might like the fact that it could be 6 in every single position.
Okay, so let's take an example of something that we counted here. Remember, I'm trying to count every valid code, and I'm trying to count every code exactly once to get an accurate answer.
But within like the 10, it still counts as an extension of the 6.
Exactly. So here I have 6 in the first position. This guy could be a 6. Any one of 10 possibilities. Let's say these are all 3s after that. So this is a code that's valid, and I'm counting it in case 1. Here, I count any one of 10 possibilities. Could be a 6. There, my 6 is in the second position. Let's say 3, 3, 3. Counted it again. And there are many other ones that I'm counting twice. And there are ones that I'm counting in this one and some other one. And there's a whole overlapping mess going on between the 5 possible groups of valid codes.
Would you decrease it then to be 9? Like
And so now you can go. We spent a lot of time on this. Now you can go and try and fix this. And every time you try and fix it, you screw something else up. It's just never, I can never really get them exactly right. Because there are 5 sets, 5 little sets in my set of valid code. And they overlap in all the possible ways. As soon as I try and get rid of one overlap, like we saw with the 3 sets, if I subtract one piece, I should actually add something else, and back and forth, and we'll go back and forth forever. Now, admittedly, that inclusion-exclusion idea does work technically, but that's way more advanced than we want. How do I avoid all of this? It's sufficient for me to see that this is not the way to go. This is, it's too complicated. It's just too messy. I'm never going to get that exact number trying to fix this manually. So I have to come up with something fancy. Fancy. Or let's not say fancy, let's say more elegant, sophisticated, refined. What do I do? So that first type of example, where you're taking the lines and going one by one, is the basic approach. It's not always going to work. So let's just call the set A the set of valid codes that I want. Let A be the set or collection of valid codes. Codes that I want to test. What does valid mean? It has at least 1 6 in it. Let's draw the Venn diagram. There's nothing really to it. Here in my rectangle, I have all the possible codes without any restriction. The ones I'm interested in counting, they're sitting right there in this circle. And there are other codes here that I'm not interested in. Just sort of visualizing what is happening here. So I want to find the number of elements in my set A. I just gave it a name, A. You can call it whatever you want. You can call it Bob. I don't care. These are the ones, the codes that I'm interested in. I tried my first basic strategy. It just didn't seem like I'm going to get the right answer. Exactly right. So I need to come up with something better. Something better. I'm trying to count how many there are. Now, we tried the direct approach. It doesn't seem to work. Let's say here, direct approach. Nothing's impossible, but it doesn't seem very efficient or realistic. I'm not going to be able to do this in a very reasonable amount of time. So let's try an indirect approach. What do I mean by that? Where is A complement sitting in the Venn diagram? What is A complement? What is the complement of a set? So if you have to shade it in, where would it be? Outside, right? So A complement is everything outside here. Now, if I'm not counting something directly, I can take every possible code, subtract everything that I'm not interested in, and what am I going to be left with? Everything in the circle that I'm interested in. I'm doing it indirectly. Take everything, take away, let's say here, codes we don't want. And what I'm left with, that has to be the codes that I do want. Is everyone happy with the idea? I tried the direct approach. It didn't seem like I was getting anywhere. So let's try this approach. It's worth taking time to look at this question. What is the universal set? It's everything. So there's no restriction on codes here. Every possible code. How many codes do I have that are 5 digits long and there is no other restriction?
50,000.
Now my basic approach works. How many choices do I have for the first position? Next position? 10, 10, 10. So how many codes do I have without any restriction? 10 to the power of 5. Without any restriction, that's almost always the easy one. Straightforward. Now there's a step before I can find this guy. I have to understand what a complement means. What are the codes that are covered in a complement? Let's say here, a complement. What kind of codes does a complement contain? If I have to say the words.
Both that does not have a 6.
If inside my circle are all the codes that have at least 1 6. Outside, all the codes that have no 6. No 6. Everyone happy with that? I have to make sure that you're happy. Well, happy might be a strong requirement for math scores. Mildly content. Or satisfied.
And have the, like the duplicates in A either, so a complement has to include duplicates.
What do you mean by duplicates?
Like, you showed like the 66333, the fact that there was like 2 of them, you can only have 1 of them because you won't have.
You mean a
an-
6? I can't have any 6.
No, as in like,
The 3.
like for the code, for the answer you want.
Okay, for example, is this about code in this A complement? Is that what you mean? That you don't want this either?
As in, you don't want like more than one
Yeah, like
of the same code in A.
Oh, no, of course. In my rectangle, every code is somewhere, either in the circle or outside, and only once. The same code doesn't sit in more than one place. So I'm automatically, by saying this, I'm counting everything. This is the number of codes inside the circle, and everything is counted exactly once. This is what this represents. There's no duplicate codes in here. No. Sorry, I misunderstood. This guy is of course valid in A complement. What is my requirement for A complement? No 6. If I don't see a 6, that means this guy, he's sitting in one of the positions, inside the circle or outside. He's sitting right there. If he's not inside the circle, he's outside, and vice versa. So I have to be clear, what is the restriction for A complement? What does A complement require for a code? No 6. Now I can go and try and count A complement, because I need it in here, to indirectly find my answer. How many choices do I have for the first position?
9.
My restriction is no 6, so I only have 9 choices. Here, 9, 9, 9, 9. So, the number of codes in A complement is 9 to the 5. So, the number of codes with at least one 6 has to be 10 to the power of 5 minus 9 to the power of 5. I don't care what the number is. You can find the number with your calculator. It means nothing to me. It's the way of thinking. It's the strategy of how to find this. That is the key. So if I take everything and take away what I don't want, what I'm left with is exactly what I want. So I should always ask myself, when I'm given a question, which is better? Which is more efficient for me to try and calculate? Do I try and count these guys directly? I'm looking for this. I know what I'm looking for. Do I try and count it directly? Or do I look at the complement, the opposite, and try and find the number indirectly? Which one's easier to count? In this case, the complement is way easier to count because it has a much clearer restriction in that I just have to exclude the possibility of a 6. A much simpler calculation to find the complement. If I take that away, what I'm left with has to be what I'm looking for. Any questions on the idea of an indirect calculation? Okay, so we've seen a bunch of things today, and it's definitely worth going and thinking about these things before the next class, because we are building one lecture on top of the next. Let's just wrap things up with example 6. That is not as hard as the previous 2 were, but worth mentioning, leading me into the next lecture. How many different batting orders are possible for a baseball team consisting of 9 players? So what is my experiment here? I'm trying to arrange these players in a row, essentially, giving me the order in which they're going to bat. So I'm trying to make a lineup. 1, 2, 3, 4, 5, 6, 7, 8, 9. This will be the first player. This will be the second, the third one, and all the way to the last one. How many ways can I choose a player to be first? 9 ways. So let's say here are 9 choices for the first person, and then 8, 7, all the way down. Let's do the second to last one. 2 choices for the second to last position, and then the poor guy in the end doesn't have a choice. I only have one person left, only one choice for the last position. So it's really simple. The number of ways to do this, the number of different lineups, whatever you want to write here. Is 9 times 8 times 7 times 6, 5, 4, 3, 2, and 1. Now, it's not going to happen in baseball, but what if I have a similar question where I want to place 50 people in a row or 100 people? Then the argument is simple. That extends easily. I just go from the total down 1, 1, 1, 1 as I'm going along the row. But this is just too messy to write down. I am lazy. I don't want to write down this every time. So what we do is we make a notation to write this in a shorter way. So a short way to write this is 9 with a little exclamation mark, and I read this as 9 factorial. The exclamation mark means factorial. And all it is a short way to write this. 9 times 8 times 7 times 6, all the way down to 1. Let's do a couple of examples. 5 factorial is just a short way to write 5 times 4 times 3 times 2 times 1. 100 factorial is just 100 times 99 times 98, all the way down to 1. So it's just a short way of writing that. So regardless of the numbers that I'm working with, the size of this guy is essentially always the same.